That's pretty loud with the door open.
Wow. That thing is unbelievable. All right, welcome back to a very active Koenigsegg factory. Now it's 3 years to the week since I was last here. It was just before they launched Jesko to the world at the Geneva Motor Show. And today we're back, we're catching up with Christian, and we're going to find out what's new. Hey.
Hey, James.
How's things?
Good to see you. Welcome.
How's everything?
Yeah, busy.
Busy? I was just saying, by pure chance, it's 3 years to the week since I was last here.
Right.
Yeah, it was on the dawn of you launching Jesko.
Well, then we have a lot to show you.
A lot to show you, yeah.
Lots have happened. I think we're twice the size of company, twice the amount of employees, and
wow.
Twice the amount of car projects, probably.
Brilliant news. Awesome. This building, I don't think, was actually here.
When you were here, I think there were a private jet and a Spitfire aeroplane in here.
Okay.
They had to move out, so we could expand a little bit.
Also, I'm aware, I think we've just walked into your office.
Right, yeah. So that little red car model there is actually the first... It's painted clay that I modeled together with David Crawford back in 1994 as the idea for the first Koenigsegg
so
car.
This is literally
where
it all started.
Yeah, absolutely. So of course, handmade and a bit rough, but the concept is there. So it even had the detachable hardtop, the short overhangs, the kind of square package, very compact. Yeah.
I'm always fascinated on what's on people's shelves in their office. I always think it's a really interesting insight into what inspires you.
Yeah. So here is actually the car that probably got me started as a 6-7-year-old. It's called the Il Tempo Gigante from the stop motion puppet movie from Norway called Pinchcliffe Grand Prix.
Okay.
So there was a bicycle repairman who lived on a Norwegian mountaintop. He built this with his 2 helpers and raced in a Le Mans kind of race against the established kind of Group C cars from the 70s and won with this contraption.
So you have the actual car
so the filmmaker's son, the filmmaker is no longer with us, but his son made a real version of this.
Incredible.
And he knew my story, so we raced with a Agera R against this car on the racetrack.
Wow.
We had to do 2 laps, that did 1 lap, and we finished simultaneously. Yeah, and here is just some kind of ideas for key holders for our cars.
So that's a key box, effectively.
Yeah, but we ended up doing a little bit differently, actually. So this is what you get with the Jesko and the Gemera. We haven't actually shown this to anyone yet. This is a pre-production unit, so it's
already looking good here.
Yeah. So
oh wow.
Here is like the key.
Oh, you're kidding me.
For the car. So
it's like a sort of deconstructed Fabergé egg almost.
In a sense, yeah. So we engineered it and designed it here, and it's very much a bespoke unit, and it's a snug fit.
Wow.
And this kind of protective egg.
I love it.
You have all our symbols here. You have the Go Squadron, Koenigsegg logo, the shield, the customer's name. It's an Absolute, the Ghost, Jesko.
Wow. And so will the customer be able to apply different engravings on it?
Yeah, we can engrave the name of the customer and then the model of the car and the VIN number and things like that. And actually the customer version of this is actually a foot as well. You can use this to store things, but this is going to actually fit here as well, so you can have it like that if you want.
Now that's a key.
That's a key holder.
That's a key holder right
or
there.
Or a mantelpiece or something.
Crikey.
You can have it like that as
wow.
well, just by itself.
So has the actual key itself, it's thinner, huh?
Yeah, it's a little bit of an evolution.
Thinner now, look. Yeah, wow.
So it's got the leather, you can have the leather of the car here. It's a machined piece of aluminium. You have the carbon frame, and then you have the leather buttons and shape of the Koenigsegg logo, and it's a bit slimmer to fit good in the pocket, and it has of course proximity sensing, so when you walk up to the car it primes and get ready and puts the setting of the driver who had this last for mirrors and seats and everything.
Super cool. So. And that'll be for both Jesko and Gemera?
Yes, for both, for all our cars going forward.
Right. Wow, fantastic. We've not even left the man's office yet. That's cool. Okay.
Yeah, and here we have
an
upright for the Jesko. It's a pretty beautiful
unbelievable thing.
Machining. as lightweight as it possibly can be, iterated probably 50 times for optimization.
Wow. So is that milled from a single piece?
It is actually. So it's not 3D printed. It's milled from a piece, but it's very much optimized for the process, and it's too complex to be forged or casted. 240 millimeter diameter dual angle contact bearing for maximum stiffness lightweights, and also to avoid heat at really high speed, as you can spread the load over more balls in the bearings. Yeah.
Crikey, it's just amazing.
The Regera vent.
Vents.
So you have this kind of
Yes.
parallelogram effect.
Yeah, I wondered how you made that. I only noticed that first when we started filming the Chronicle series, and we managed to get a lens small enough to actually highlight that.
It was actually an idea from another Swedish car originally. Saabs did this back in the days, but not to this level.
Sure.
But we thought it was just a Swedish way of doing event, and it's very clean. You don't see the angle so much. It's more kind of elegant. Brilliant. You have a very nice feel. We're delivering the absolutely last Regeras as we speak.
Yes.
Next 2-3 weeks they will all be gone.
Wow. Okay.
And the Jesko is on the line and getting ready to get out.
Exciting.
Happy to show you.
Let's do it.
So yeah, here's engineering office.
Phenomenal.
Mechanical engineering, transmission, engines, bodywork, chassis, carbon fiber, simulation, electronic software, hardware, project leading, all in the same space, just above.
These guys have got the best view in the house as well.
Yeah, so we really want the engineers to be close to the physical parts they develop. So you're running into the prototype mechanics and the parts and the vehicles. It's all tied together.
Fabulous. Wow. So all of this did not exist.
Exactly. And we're doing a copy-paste almost in the hangar next door, and then we have the final hangars of the old hangars.
Look at this.
Hey guys, can we have a little quick look inside?
Absolutely.
Yeah.
So this is an actual.
This is our one of our development dynos.
Okay.
Where we can put. This is a Jesko engine running right now. We have these trolleys, so we can quickly in 1 hour change a 3-cylinder trolley to a V8 trolley and run that instead.
In an hour?
In an hour.
That's a quick turnaround.
It's quick connects on everything. So just snap it on, undo it, and put a new engine in. So this can go over 2,000 horsepower and over 2,000 Newton meters, this dyno, so it's kind of good for our needs. And then we're building next door, which will be finished in 3-4 months, the world's most extreme four-wheel drive, four-wheel torque vectoring chassis dyno, which can go up to 3,000 horsepower and spin the wheels up to 540 kilometers per hour. And it's also a climatic chamber that you can go down to minus 30 degrees and up to ambient of 60-70 degrees.
During a test?
During a test, exactly. So we can do cold starts and we can do high-speed setups and maximum power for all the models we can conceive for the future.
I suppose one of the challenges going forward with dynos is EVs generate a huge amount of torque, like massive torque.
Absolutely. So it is an electric dyno. So we have these huge coils on the roof dissipating the electric heat and stuff like that. We're trying to regenerate that into the floor heating and stuff, so we don't waste the energy as well.
Okay. Wow.
This dyno you can flex fuel. Now we're running on alcohol here, E85. You can run on 100% ethanol or methanol or Vulcanol by just a switch of buttons.
So you're able to pump in and test different fuels?
Yeah. During a test we can run different fuels.
Mid-test?
So we switch over because it's flex fuel. So we're flexing between different fuels and setting that up as well.
For anyone just tuning in, you might have heard the word Vulcanol there. Would you mind just giving us a top line of what that is?
Yeah, so it's basically a fancy word for environmentally friendly CO2 neutral methanol that derives from the natural CO2 emissions from volcanoes. That's how they invented it. You can basically cork any CO2 kind of chimney and convert to methanol, but they invented it taking it out of the volcanoes on Iceland. It's an Icelandic patent. I think they even got some kind of Nobel Prize for it. And so you convert natural CO2 outflow into methanol, so it's completely recycled. And it's a cool name. I like Vulcanol.
I was going to say, the fact that it comes out of a volcano makes it like 10 times as cool.
Exactly.
I love the use of actual Koenigsegg pedal box down here. Brilliant. Oh wow.
loud with the door open.
Wow, that thing is unbelievable.
And we actually have the whole
special.
plate, the whole metal plate is on air cushions because I mean we have 200 engineers sitting up there.
Vibrate the room to
only hear it. You only hear it very minutely. It's so
Upstairs.
well dampened, but with the door open, it's
a different story.
Here is actually the 3-cylinder, the TFG, on one of these trolleys I just mentioned.
Yeah.
So that's ready to slot in when we're done with that, and it has a lot of test and measurement equipment on it, as you can see.
So this is effectively what will end up in Jumeirah.
Yeah, I mean this is a test engine with a lot of extra stuff on it, but it looks like a horn. I mean, like I don't know what it looks like.
Looks like some
weird
Frankenstein
stuff.
engine.
Exactly.
But yeah.
So, but yeah, the engine is.
And this
in
will
there.
run free valve.
It is running free valve. Yeah, absolutely, as you will experience in the car.
So the building we're in now then didn't exist the last time I was here.
Well,
right?
the shell existed as an airplane hangar, and there were airplanes in here. Actually, there was a Spitfire in here.
No, really?
Yeah, it's a private guy owning a Spitfire
Wow,
and
that's
some
cool.
other planes he had in
Yeah,
here. But they found a roof over their head elsewhere, so we could move in here. And we converted this kind of just open space into what we call our pilot plant, where we have our test cars. And upstairs we have our engineering office for mechanical design, engine design, transmission design, electronic software, everything combined up there. So they're very close to the action, what's going on downstairs here. And here we have what we call the TC1 Jumeirah.
This is a massive moment. Okay, so is this the first driving prototype?
This is the first driving prototype. So we started driving this last summer.
Right.
And we're still driving it, and we're building TC2 and TC3 as we speak, which will be a little bit more refined. So we can say this is the A sample, the first version of a driving Jumeirah, apart from the show car you have experienced, which also drives, but it's very much
incredibly
not
slowly on
the
battery
real car. This is fundamentally very similar to the production car, but not fully refined yet.
So this has battery under.
It's battery under.
Engine in. Free valve.
Free valve. Four-wheel drive, torque vectoring, but it's very much a test car. If you look inside, it's full of testing equipment.
I'm not sure if this has been shared yet, has it? I've not seen it.
No, it hasn't. We haven't really. I mean, someone might have caught us here in the Valhall Park behind us, driving around, but otherwise we haven't really shown it.
But as a moment, this is really tangible. This is like really happening here. You know, it's super cool. Wow.
And it's kind of. What you see is what you get here. It's mostly test equipment in here, of course. We're just logging everything.
Right.
Kind of close to the final thing, but of course working on refinements.
Sure.
So we've just installed our own EPAS steering rack, a new brake system. So it's kind of going through the motions. We're putting in next generation inverters and electrical motors that is closer to the production that we unveiled quite recently.
Those are now developed and constructed in-house, right?
Absolutely, and we will have a look at that later today. So it's all in-house developed to suit this perfectly.
David, Quark, and Terrier.
Exactly. So the Terrier is actually not for this. The Terrier we put together in the press release to show what if you combine the 6-phase output David with two Quarks and 2 small planetary gears, you get the lightest, most compact, most powerful per weight and size electric drive unit we've ever seen. So of course we can use that for something fun, or we're also offering it potentially to others if they want to use it.
Yeah. So how far through its development stage are we?
Well, percentage-wise, it's difficult to say, but it's becoming more and more close to the real thing. Basically, mechanically, it's very, very close. It's software is massive in this car. I mean, everything is software-based, and we're kind of bringing it up together. So, for example, the engine is now running, and it's propelling the car, and it's charging the battery, and it's running pretty smoothly. But what we will do quite soon is we're revving up to 4,500 now in the car. We're revving higher in the dyno, but we're just kind of stepping that up as we go to its 8,500 max RPM, and also kind of bringing in that emotion that we can kind of flare it quickly and rev it. And with this car, as you can disconnect the prop shaft to the front with the hydraulic clutches on the front drive unit, you can rev it freely as you have a, let's say, as the neutral, because it kind of has a neutral, So, and when you use the paddles, we have different programs to suit different tastes of driving. So you can have like a downshift, which means you're like jumping the equivalent of 3-4 gears and hit 7,000-8,000 RPM, or you can just have this super smooth kind of CVT feel, if you like, because there's no limitation on what you can do.
So in one shift, you can simulate a jump to.
Yeah, you can be at 2,000 RPM, flooring it with a lot of torque, and then you pull it, and depending on how hard or how long you pull it, you will shoot up to a higher RPM and lock it there and go like you're in a lower gear.
Wow. Okay.
So it will have this super exciting, engaging, direct drive.
Wow.
Which is at least as fun or more fun than a gearbox.
You're really getting a good feel for the scale of these doors.
Yes.
I think one of my favorite features of the car is no B-pillar.
Right, right, yeah. You can. We have a video
amazing
on our YouTube channel where we have 2 persons which are over or just under 2 meters tall, just walking in to the car from both sides, not moving the front seats backwards or forwards while getting in all of them simultaneously. So that is the beauty of the no B-pillar and accessibility and space inside.
It's beautiful, isn't it?
Of course, if you have a very low garage,
has it got a sensor?
It has a sensor here. Right. So it would stop earlier and you would have to go around it.
Sure.
But most garages have this kind of height. It's not that tall. It's like 228 meters. So it's like under normal roof height.
Yes.
But it has that opportunity to stop early, and you can still easily get in and out even if it's in this angle.
Sure.
It's just not as simple.
Yeah. Wow.
Let's put it like this. It's much lower than a Tesla Model X gullwing door.
Sure. Yeah, of course.
Yes.
So the perks of the 800 volt isn't just the charging. You can make the fundamental system lighter.
All the wires are lighter,
much lighter.
thinner. Basically, the higher voltage you have, the thinner cable you can have with the same amount of, let's say, power. Meaning, you can have the amperage. If you have the same amperage as 400, 800, basically you have double the power. So and amperage is what dictates the gauge of the of the cable. Yeah.
Have you had to upgrade the hinges for the
it's a little bit beefier.
Looks great.
Yeah,
it's like from Transformers.
Yeah, exactly. So, I mean, the center of gravity of this car is super low, but since we don't have a free kind of, it has a frame around here.
Right.
And the reason why we have this kind of more traditional old school sports car window is because this glass curves so much, so you could not roll it down and it would be too big.
Right.
So we're doing it this way. I kind of like it as well. It's
cool.
Kind of a hark back to old cool Countaches and McLaren F1s and so on.
Yes.
But it's basically because it's too much roll here, which we need for aero and the shape of the window. But that also means that if you would end up on the roof, it's not enough to crack the glass.
Right.
I mean, you could, and then you would have to rip this out. It would be a little bit of a headache if you want to open the door.
Sure.
So we're also building in explosives into the hinge.
Okay.
So, and then you have these
literal blast doors then.
Yeah. So you have these emergency openers. Normally you just press the button. Everything is robotized with Autoskin.
Right.
But if you're upside down, and first of all, you can always use that normally as well if you want to. But if you're upside down when you pull that, there's also a little explosive unit going off in the hinge, so the door just falls to the side.
Door falls off. I love how he throws in casual things like, normally it's robotized with Autoskin.
Right.
And that will run the screen which maintains its horizon.
Yeah.
Wow, that is, look at that. That's so cool.
And this is an early version. We have a higher processor speed now in production, which smooths it out even more, and it's very responsive and oily, which is important for the feel. So we have a couple of Jesko test cars here, going through the paces. I mean, now we are officially in production in 2 days, and you will see the line. But we're still refining some software and things like that, and putting learning how to fully service the cars and doing service instructions and stuff like that. But here you can see a little bit under the skin. Of course, you have the triplex suspension, which is very advanced on the Jesko to keep the car.
So this runs triplex on the front as well now,
exactly.
Right?
Not the absolute, but the attack version.
The attack version. That's what it's officially called, huh?
Yes. So here you can see it.
Wow. Yeah. So with the attack version, if you want to take the roof off, you leave it in the garage.
Yeah, exactly.
Okay.
This is one of the few Koenigsegg's. I mean, the one-to-one was similar. So we sacrifice a big part of the luggage space to accommodate maximum downforce. And here you can see, this is a test car, so you have all these strain gauges stuck on here, so we can see exact load cases for setup, and also double check the structural integrity compared to the load case, so we haven't done it over or underdone the weight of parts.
So the difference in the Absolute is less downforce, but higher the ultimate
much
top
softer
speed.
suspension because this needs so much tougher suspension to hold the car, well, avoiding it pressing into the ground.
Yeah.
And of course we do have downforce on the Absolute. It's a couple of 100 kilos instead of 1,000 or whatever it is here.
Wow.
So
is it that high on this?
Yes.
It'll be interesting to see what the final split will be between if people are opting for a.
Yeah, I think what we're seeing for the first batch of orders is about 1/3.
Okay.
Yeah.
Interesting. Wow. It's a hard choice.
Yeah.
Hard choice.
Yeah, it's very difficult to see.
It is, yeah, that's it.
It is.
So if you're just tuning in, you make it 125 of these cars, right?
Yeah.
And you have to make a choice. You're going to go for Attack or Absolute.
Correct.
Okay, and Attack is more track focused, a bit more hardcore driving experience, and Absolute is, I remember you saying it will be your fastest top speed car ever.
No doubt about it.
You can't see from a physics point of view that you can achieve much more.
It's much more power and much slipperier than we've ever done, with a 9-speed gearbox instead of a 7, with tighter ratios, with a higher, taller top gear, and easier to get there. So yeah.
I'd be interested to hear in the comments, would you go Absolute top speed or would you go Attack?
Yeah.
You know?
And the cool thing about the Absolute, it's going to be super fun on a track.
Yes.
Because a little bit softer sprung and with a little bit less downforce, of course you don't have the same cornering speed, but it's very predictable on the limit because it's a little bit less on the knife edge, of course.
Sure.
So, and this one has the more extreme tires as well.
Sure.
The Attack version. So.
Yeah. Is the majority of the downforce or ground effect?
It's both, of course. But with this huge wing and the huge front splitter, it's a lot coming from above. But of course, we're doing whatever we can underneath as well. So if you compare to the Valkyrie, of course, it's I don't know, maybe 80-20. Here it's maybe 50-50.
Right. Cool.
But it's much more of a daily driver as well.
Right.
We're building the first Absolute over here. So here you can see the
aero is vastly different.
Completely.
Yeah.
Here's a good example to see how lightweight and slender these chromolubedinium wishbones are. We've been thinking of making carbon fiber wishbones and so on, but what's nice about having a steel wishbone is the compliancy in a crash. You can bend it a little bit.
Sure.
So and it's really lightweight and stiff with this kind of straight tubes with these nodes that are partially 3D printed or very extreme machinings.
The componentry on this it's almost a shame to put the body on it. It looks.
And here you can see how compact the transmission is, the 9-speed transmission. I mean, the rear part of the tire is around here, so it's all within kind of the axle. It's nothing sticking out back at all. It's super compact, and the engine is really far forward and down in the chassis.
So the 9-speed box, that's capable of dealing with torque similar or greater than a single clutch?
Yeah, I mean, we've designed it for 1,500 Newton meters.
Newton meter torque?
Wow. Yeah. So that's the highest gearbox or transmission we've ever had.
Yeah, but it has the shift speed as well, as fast as you want.
Yeah,
right?
I mean, well, actually, there is no shift speed because we're never shifting gears. We're only clutching. So it's you have 3 times 3 clutches, and then and 3 times 3 becomes 9.
Them. Wow.
Yeah, it becomes 9. So it's a compounding effect.
Yeah.
And then you have your final drive. So when you're shifting between these clutches, or when you're choosing between these clutches, not shifting really.
Yes.
You're slipping in and out of them, but you never lose torque. That's a similar thing if you do the right thing in a DCT and you shift in the pre-selected gear. You don't have to lose torque, and we don't have to lose torque between 3rd and 7th if we want, because we just choose those instead of those and those. So there is not anything going through or pre-selecting. Every gear is pre-selected all the time.
All the time.
If you see what I mean.
Yes. It's bonkers.
So.
And look at the size difference.
Exactly, because in reality there are only 6 gears, 3 times 3.
Right.
So it's the size of a 6-speed, but you get 9 due to compounding, and then you don't have any shifting mechanisms because they're not shifting; they're just clutching.
I'm going to have a strong cup of coffee after this one. It's, I mean, it is a mind blast. It's unbelievable.
So here you can see again, we don't have
so different suspensions set up here.
The wishbones are really beautiful.
Gorgeous,
and lightweight.
The uprights are a work of art as well.
Yes, yeah, you can see them here, and you can see massive brake cooling.
Yes.
You have one direct pipe here, carbon fiber blasting there. You have this shooting from the front, air intake. and these huge, beautiful machinings with 240 millimeter dual angle contact bearing. The reason why we have the largest bearings in the industry is because the larger bearing you have, the less heat you get at high speed, because you can divide the load over more surface area in the ball bearings. And also the bell housing here, because we put in a little bit higher effort than anyone else. They're all clocked for each corner, because you're only braking, I mean, okay, when you're reversing, you're braking in reverse, but that is not the same load as continuous pounding forward. So this is the forward braking kind of material holding against the force, and that's the reverse. Normally you have equal shapes, but then you have on the limit on forward and unnecessarily too much material braking. So we kind of move this material over here to make it lighter.
Crikey.
And then of course you need one unique for each corner, which makes it a bit more expensive. And then we also shaped it. If you film in here, you can also see on the back side of the bell housing, it's a little bit fan shaped, and you can see how it goes up and out here. So we blow air on the surface as well from that side.
It has a small pinch point.
Yeah, exactly. So it can release air
to allow for breathing.
And then you can see kind of the shoveling effect on the, if you look in there on the surface.
Oh yeah, it's almost a fan at the back.
Exactly.
There. Wow.
So you can do that when you
and
have
these
them
housings are specific to each corner.
Exactly, because that if you put that on that side, it will be the wrong direction.
Yes.
If you put it there, it's the wrong disc and the wrong offset. So therefore, you need one for each corner.
Wow. Okay, that's that. You know, the reason why it's good to walk around with you is because there would be so much injustice if I spoke about these components. I'd be like, oh, that looks nice. You know.
We're really going into depth.
Yes.
On everything, and given, let's say, the torque, the power, the capability of the car, the features and functions, it is as light as it possibly could be. There is one kind of two giveaways. We have an amplifier for the stereo system, and then we have this unit for the auto skin, which adds about, with all the hoses and everything, adds about 5 kilos to the hydraulic lifting system and aerodynamics. But it gives you this super nice feature of not having to touch the bonnets and open and close the doors and everything automatically. So I think,
and it is pure theatre, isn't it?
Yeah. Of course, you can rip that out and save 5 kilos, but I think it's 5 kilos well spent.
The functionality is, that's it.
And we anyway had the pump. We anyway had the reservoir actuator and the tank and the control systems. Just adding that distribution box with some hoses.
Right.
And
wow.
And that was it. So, and some software, of course.
Sure.
Here is a test gearbox on a pallet, so you can see how compact it is. This is an early version with different colors.
I mean, a twin clutch box would, I mean, if we were to stand one, it's like up here.
You would be
up
here. And another big, 30, 40, 50 kilos.
More weight,
And then you would only have 7 gears and probably only 1,000 Newton meter torque capability.
Torque.
So, but on top of that, in the weight we describe, you have the starter motor, which normally sits on the engine.
Sure. Yeah, of course. Wow.
And normally you have a flywheel and clutch. But there, whatever is needed of that is inside here. All the clutches, I mean, there are 6 clutches plus a reverse clutch, and there is no flywheel on the car. We just hook it up directly to the crankshaft into the input shaft. That's why it's the fastest revving, combustion production engine in the world. So there's no mass.
It blows my mind, honestly.
To speak of.
Let me look at it.
It's a work of art, I would say.
It really is. The bolts themselves, are these a proprietary fitment for you?
Yeah, I mean, basically we have a design for each position.
Its own bolt?
Yeah, pretty much. Yeah, each position we design the bolt in length and stiffness and waist and material, if it's titanium or steel, depending on what's needed.
Per fitment?
Per fitment, yeah.
That's unbelievable.
Well, that's...
Yeah. That's how you get this, I suppose.
Exactly.
Yeah. The interesting thing about, what constitutes a hypercar is often the stuff you don't see, right?
Right.
It's this stuff which makes them the completely next stage of
you could never go into this level of detailing on anything costing much less. It just wouldn't be possible. And of course, they need to stand out. They need to have unique features and functions and be lighter, stronger, safer, more exciting somehow. And the only way to achieve that is going into
extremes, right?
into the depth and extremes in as many areas as possible.
How do you cultivate that culture and mindset within the company?
I would call it, or I would say it's just something that happens.
Right, okay.
Walking around talking, this is not good enough, why did we do this, why didn't we do that?
Sure, yes.
Let's just redo it,
right.
Let's aim for higher.
It eventually just
and then people
becomes
just
a mindset.
become like that, I would say.
Yeah. So over the years of developing all of this tech, have you had any learnings which have been able to get filtered down into other industries or, or cars, or should I say more mass-produced cars?
So if we're talking about the TFG 3-cylinder, if we talk about our electric motors, our control system, our OTA, our transmissions, all of these components, we are today working with other companies looking to implement for something else.
Brilliant.
And actually it's kind of, in a way, a little bit disturbing us because we're so busy doing what we need to do anyway.
Yes.
But we're starting to realize it's crazy not to share this technology in a broader audience when those things actually can be produced at a higher volume, or than just having fun with it ourselves. And it also enables us, of course, to even further develop those systems and products that compared to if we only did it for ourselves. But in the short term and until now, it's more a disturbance than a gain, but we're thinking long term.
Yes, yeah. Brilliant.
Yeah, let's go upstairs and I'll show you the development environment. So this is our engineering landscape. We basically have crammed our engineering and development resources into this top floor in this new hangar, where we have the pilot plant, let's say prototype development downstairs, and all the engineering, software and electronics design up here.
Wow.
Behind us here we have simulation.
Okay.
It's structural simulation, CAE, CFD for aero, thermal simulation, and other types of simulations, this group of
I mean, you really do everything in-house, don't you? Like a lot of this stuff would be outsourced, wouldn't it?
That wouldn't be
amazing.
That I guess would not be unusual, but we really think it's critical and vital to have it in-house. This is electronic hardware development, where we do circuit board and then software right behind here. Here you have a prototype of the cup holder.
Okay, look at this. How cool is that? So, wow. Okay.
It's probably the most extreme hot-cold cup holder we've seen. We've really spent a lot of energy and time in getting this work. So it's actually thermally simulated aerodynamically and thermally with our simulation tools. Maybe Boris, do you have any more information about it?
Hey.
This is Boris Baskowitz, head of
Good to meet you.
electronic design.
Wow. So
that's our thermally coupled cup holder, so we can heat and cool at the same time. It's designed to be able to work in Dubai, just like in Finland or in Sweden.
Sure.
So
brilliant.
It's quite a cool project. This is a prototype, so you don't see all the electronics that would be in the car. It's a prototype electronics, but that's quite nice.
And of course, we don't want people to burn themselves or freeze their fingers to oblivion, but it still needs to have a lot of power. So we can sense if there's something in there and put more energy or less energy into the cup holder.
When it's there.
When it's there, exactly.
Right.
Can you imagine that there are safety requirements for cup holders?
For cup holders? Well, that's definitely the poshest set of cup holders I've ever seen. So,
and here you can see a little bit under the surface of some control boxes. We have really skilled circuit board designers to shrink and minimize the size and complexity for the amount of function.
So this is what is controlling the engine, the TFG engine.
Wow, is it?
And so it's like a folded electronics. So we can make it as
more compact.
So that's the control board of the engine.
Mil-spec connectors.
This is not standard connector stuff.
No.
This is a different world.
Yeah, history-wise, they came from jet fighters. So they are using all the European jet fighters.
So you've got jet fighter connectors in your car.
Yeah, exactly.
And if you compare this this engine controller compared to a normal engine controller, what would you say about it?
Well, it's designed to be used in different type of cars, so either TFG or V12, V8, and this kind of car. So it's very versatile. It's a lot of diagnostic. It's you can update it over the air. So a lot of tuning capability also. So we can tune exactly to our engines. Super fast, multi-core CPU. I mean, that's the top you can do
yes.
To control an engine.
And then we of course infuse it with full onboard diagnostics, so we can certify the car around the world. It's very exciting, and it gives us super high degree of freedom and flexibility.
Sure.
And then all these, what we call them nodes, these controllers, all the nodes are speaking the same language, part of the same family, and speaks to our cloud and can be updated from our cloud and down into each car worldwide. All these controllers, they have basically 2 memory slots.
Right.
So whether your car is parked or out driving, when we have an update, we download it in the background in one of the 2 memories which are always available. So it's just happening in the whole car simultaneously in the background. And when you get the information on your screen, it's you have an update, you click it, zoom, boom, it happens almost immediately because we just switch the memories and then the other one is available.
Brilliant.
So the experience is like, whoa, that was a fast connection.
That was a fast update, yeah.
It's like, wow, this
Great
is like
idea.
20G. And maybe a few words on the inverter.
Sure.
Yeah.
So we are using the latest technology in semiconductors. So we are using what is called silicon carbide. That's a new way of designing semiconductors for switching high power and high voltage. That allows us to raise the battery voltage to what is needed for the power that we require, and to raise at the same time the current into the motor, and at the same time shrink the whole inverter. The inverter is what is converting the battery voltage into a motor voltage, so 3-phase motor. And
here you can see a little bit inside.
That's basically what we have done here. This is technology directly from Formula One that we brought with us.
Wow.
And that is what is racing now on the tracks.
Is it?
Yeah.
Really? Wow,
Really,
incredible.
yeah.
This tour's making me feel real basic. So this sits in the floor pan, effectively, of the Jumeirah.
So it's very compact. It's the most power dense to size and weight battery pack in the world. The Regera had the record before, and now this takes it to the next level. And it's using our patented dielectric cooling liquid that we already have in the Regera, and then we're kind of taking all the lessons learned and taking it to the next level.
It's all about mixing highest motorsport technology with military technology also sometimes. So it's using some...
Sounds highly cool.
Yeah.
Sounds awesome.
Picking the best from everywhere you can.
Each industry and going, wow.
Big,
it's a small pack.
Tesla battery.
Okay.
It's because we have a hybrid car, so we don't need energy, but we need crazy power. So that's the most powerful battery you could find.
Wow.
In that, especially in that size. That's why we have to use components that you don't find on the market, normal market. I mean, the current, the density of the current onto the bus bars, into the cells and everything is insane. It's just insane.
Yeah, so from around 8 kilowatt hours, we can extract 1 megawatt of power.
Seriously?
Yeah.
I don't know how you've done that.
It's
just amazing.
And the weight of the battery pack is, I think, 160 kilos.
Well done. So brilliant. Thanks very much.
Yes, we have these kind of areas here and there where you can sit down and have lunch.
Yeah.
Very close together.
It's got a nice vibe about it here, you know. So you're testing extremes of -40 and plus 80.
Yes, 85 I think we go up to.
Okay, and in there is a infotainment system.
Correct. This is the controller for the infotainment system, the bird's eye view parking, the Apple CarPlay, the climate control, and actually the 4 and 5G modem to communicate for over-the-air updates. So right now it is functioning over this cable to this laptop, running it and cycling and testing
so it's actually running in there. It's running as well as doing a temperature.
Exactly, at minus 39.5 degrees.
Right.
To see that, because of course with a lot of plastics and solderings and so on, a lot of movement when it's hot and cold. So you cycle it up and down and test it, that it works in all these different environments.
Start to look good value actually.